Hello friends, you are watching channel number Collage. This is my sincere effort to help you understand basic mathematics in a simple and easy manner. In this fifth lecture on vectors, we will discuss applications of vector product. The first application is finding resolved part of a force F bar. Second is finding work done by a force. And third is how to find moment of a force about a point. Let's discuss one by one. We will discuss some applications of vector product. The first among them is the resolved part of a force F bar. Let a force F bar acts at a point O. A cap be the unit vector along ray OA. This is ray OA and A cap is the unit vector along ray OA. The resolved part of force F bar along the unit vector A cap is another vector defined as F bar dot A cap times A cap. If theta is the angle between F bar and ray OA, this angle, then F bar dot A cap will be a dot product which will be mod F bar multiplied by mod A cap cos theta. Now mod A cap will be 1. So F bar dot A cap will be mod F bar cos theta. Therefore, the resolved part of force F bar along A cap will be as defined by this: mod F bar cos theta, which is F bar dot A cap times A cap. So that is mod F bar cos theta A cap. What will be the resolved part of a force F bar along x, y and z axis? Resolved part of F bar along x-axis will be F bar dot I cap times I cap. Along y-axis will be F bar dot J cap times J cap. And along z-axis will be F bar dot K cap times K cap. We have to find the resolved part of the force F bar equals 2I cap minus J cap plus 3K cap, which is this force, along a line containing the vector I cap plus 2J cap minus 3K cap. We will assume A bar to be I cap plus 2J cap minus 3K cap, which is this vector. The resolved part of F bar along A bar will be F bar dot A cap times A cap. So first we will find out A cap. So A cap is A bar upon magnitude of A bar, which is mod A bar, which is this vector. It will be I plus 2J minus 3K, which is A bar, under root 1 squared plus 2 squared plus minus 3 squared, which will be 1 squared is 1, 2 squared is 4, and minus 3 squared is 9. So a cap will be I plus 2j minus 3k divided by under root 14. We have f bar equals 2I cap minus j cap plus 3k cap, and a cap equals I cap plus 2j cap minus 3k cap upon root 14. Now f bar dot a cap will be a dot product of this vector and this vector. So it will be 2 multiplied by 1 plus minus 1 multiplied by 2 plus 3 multiplied by minus 3 divided by root 14. It will be 2 minus 2 minus 9, which will be minus 9 upon root 14. So we get f bar dot a cap as minus 9 upon root 14. Now the resolved part of f bar along a bar is f bar dot a cap, which is this, multiplied by a cap, which will be minus 9 divided by root 14 times a cap, which is this vector, which finally will be minus 9 upon 14, because root 14 multiplied by root 14 is 14, times I cap plus 2j cap minus 3k cap. So this is the resolved part of f bar along a bar. Work done by a force. If a constant force f bar, this one, acts on a particle at a point O, moves the particle from point O to point P, point O to point P, then work done in this displacement OP bar will be W equals force multiplied by displacement. Force is F bar and displacement is OP bar. This is a dot product of F bar and OP bar. And if the force F bar is perpendicular to OP bar, then the work done will be 0, because we know that dot product of two perpendicular vectors is 0. A particle is acted upon by a force F bar equals 4I cap plus 3j cap plus k cap, which is this force, at a point I plus 2j minus k, this point, displaces it to the point 2I plus 3j plus k, B point. We have to find the work done by force F bar. F bar is 4I cap plus 3j cap plus k cap. OA bar is I cap plus 2j cap minus k cap, and OB bar is 2I cap plus 3j cap plus k cap. Now we know AB bar equals OB bar minus OA bar, which will be 2I cap plus 3j cap plus k cap minus I cap plus 2j cap minus k cap. This will be 2 minus 1, which is I cap, 3 minus 2 which is j cap, and 1 minus of minus 1 which is plus 1. So k plus k will be 2k. So AB bar will be I cap plus j cap plus 2k cap, which is this vector. Work done by F bar is F bar dot AB bar. This is F bar, this is AB bar. It will be 4I cap plus 3j cap plus k cap dot I cap plus j cap plus 2k cap. It will be 4 multiplied by 1, 3 multiplied by 1, plus 1 multiplied by 2. It will be 4, 3 and 2. So the work done by F bar will be 9 units. Moment of a force about a point M bar. The tendency of a force to rotate the body about a fixed point is called the moment of force M bar. Force F bar acts on the body at point A. So this is the body, this is point A, and force F bar acts on the body at point A. Now this force has tendency to rotate the body about point B. So force F bar rotates the body about point B like this. The vector BA bar cross F bar, BA bar cross F bar is called the moment of the force F bar. So M bar equals BA bar cross F bar. The action of the force F bar equals 4I cap minus 3j cap passes through the point A, whose position vector relative to point O is 2I cap minus 2j cap plus 5k cap. So this is the position vector of point A relative to point O. Find the moment of F bar about O. Moment of F bar about O will be M equals OA bar cross F bar, which will be 2I cap minus 2j cap plus 5k cap, which is this, cross 4I cap minus 3k cap, which is this. Force F bar 4I cap minus 3j cap acts at point A of the body, whose position vector relative to point O is 2I cap minus 2j cap plus 5k cap. We have to find the moment of this force F bar relative to point O. It is given as OA bar cross F bar, which is a determinant ijk 2 minus 2 5 4 0 minus 3, which will be I times 6 minus 0 minus j cap times minus 6 minus 20 plus k cap 0 plus 8, which will be 6I cap plus 26j cap plus 8k cap. So this is the moment of force F bar relative to point O. 6I cap plus 26j cap plus 8k cap. A force of magnitude 3 units in the direction of 2I cap plus 3j cap plus 6k cap acts at point 1, 1, 1. This is the point A, 1, 1, 1. Find its moment about the point -1, 2, 3. This is the point, and this will be OA bar. Now, force of magnitude 3 units in the direction of 2I cap plus 3j cap plus 6k cap will be F bar equals 3 times the vector divided by its magnitude, which will be 2 square is 4, 3 square is 9, 6 square is 36, which will be root 49. So this force F bar will be 3 by 7 times 2I cap plus 3j cap plus 6k cap, which will be this force. Force F acts at a point A on the body. We have to find the moment of this force about this point O. So for that we have to find vector OA bar. So OA bar will be 1 plus 1 times I plus 1 minus 2 times J plus 1 minus 3 times K, which will be 2I cap minus J cap minus 2K cap. So OA bar is 2I cap minus J cap minus 2K cap. Now we have to find the moment of force F bar about point O, which will be OA bar cross F bar equals OA bar cross F bar. It will be a determinant 3 by 7 times I cap, J cap, K cap, 2 minus 1 minus 2, 2, 3, 6. It will be I times minus 6 plus 6 minus J times 12 plus 4 plus K times 6 plus 2. So it will be 0 I cap, 16 J cap and 8K cap. OA bar cross F bar will be 3 by 7 times. We will take 8 common from 16 and 8 and write 8 times 2J cap plus K cap. So moment of force F bar about O will be 24 by 7 times 2J cap plus K cap. In the 6th lecture on vectors, we will discuss collinearity and coplanarity of vectors. If you like this video, please click the like button. Share this video with your friends and relatives. Do subscribe this channel. Thanks for watching. Keep watching Number Collage. Thank you.